we have two inlet valves that they are just easily they are, as I said, when you see a valve situation is in parallel with the pipe direction, it means that the valve is open. If you turn it the crossway, it means that the valve is closed. So the valve inlet valves are on. This is the domestic flow meter that shows us the cubic meter how much gas you are consuming here. Then gas flows behind this bench and gas bench, and we have an emergency box. That's if we push this red button, automatically the inlet gas will be disconnected from the main supply, and so we have allowance to use gas for 6 hours. Anyway, so this is the pressure drop rig. You can see gas flows. This is the inlet tap of natural gas. Okay, then natural gas flows from using this tube to the first pressure sensors, then pass through the 10-meter pipe with 4 bends, and the second pressure sensor. And let me turn it on. The light would be better, maybe more visible. And then we have a Bunsen burner at the outlet stream, at the outlet point, that we are going to burn the gas here. Okay. Then just the one question: there is no gas burning. I mean, we are not going to burn gas. We don't have any flame here. So why these two sensors are showing me pressure? Why we have pressure inside the pipes? It's the one question. I can give you an answer now. Just think why we have pressure and these figures on these two pressure sensors. What do you think? There is no gas flows, but we have gas inside the pipe. Just a second, think about it. If you want, you can pause the video and think, because I'm going to answer. Okay, count 3. 1, 2, 3. The answer is we have static pressure inside the pipes. Because of that, before just recording this video, I turned the gas lines and burned some gas here to test the pressure drop rig on the safety points of you, to check everything to make sure that it is safe. Because of that, right now the situation of this valve is off. It means that gas is not supplying, it's not flowing inside the tube, but from the previous one we have gas inside the pipe. We call it static pressure. Okay, so let's come back to our test. My friend, extractor arm, she's ready to here to be on. We can move it and put it on our Bunsen burner to vacuum the flue gases. Then the next step, you can see we have designed a valve here for Bunsen burner. The situation of this valve is crossed, so it means that it's closed. I'm going to open the valve. Okay, and open this valve. We have gas. Just turn the light on. We have gas. You can see the flame. Beautiful flame we have. And you can see the direction of the flame is through the vent system. If I change the Bunsen burner inlet air amount, you can see the flame. There is no oxygen here, very lack of oxygen. So I increase the oxygen level of Bunsen burner to have a nice flame of natural gas. So we have flame. Our vent is working properly, working very good. And So the next step is just seeing the pressure drop. The pressure drop showing me just I have like less around 0.1 pressure drop on this 10-meter pipeline, and the pressure sensor is highly accurate. So there's no like, because the flow rate is very small here, just Bunsen burner 1 point like 1 pressure drop. Sometimes it's just like fluctuating here between 25.2 25.3 4, and so it seems that there is no pressure drop, we can say. Static pressure here, just I turn the gas off and leave the Bunsen burner on. You can see that there is no pressure here now, because sometimes it's showing the minus 0.2, because this zero, the inlet is zero, and here the zero pressure. There is no pressure, but we have air inside, and also now the maybe just the gas, and so just this atmospheric pressure, and so is the pressure gauge. So I put the 0 here for this one and 0 for this guy. Should be fine. Yeah, you can see that's minus 0.1 pressure drop. And even when I'm just turning it on and turn the Bunsen burner, you can see how pressure drop, how pressure will be increased. And I change here the unit of the pressure sensors to bar instead of millibar. You can see that there's different units. You can put your pressure sensors to measure the pressure. Here, if you go to the configuration section, and you can change the like PSI and custody and different like units of pressure. Just for low pressure, just it's better to put on millibar. Then you can press the enter, so you can see this the like in millibar 25 millibar gauge. Just I said that's operational pressure of the like distribution pipelines is low pressure, and at least should be 1 point something. This is the 1 point something here, so why we call it millibar. It's not millibar, 25 millibar is higher than 1 bar. So it's the gauge, we are just reading the gauge, pressure gauge instead of like absolute pressure. So just you can research and investigate what's the difference between so let me change the units to millibar, enter. You can see how pressure drop we have here now. It's just 0.2, 0.2 millibar is the pressure drop. And just research about the pressure gauge is another question here. So the results and the outputs of our experiment today was, so that when we have 10-meter pipe, okay, it bends and like it's just only 0.2 millibar pressure drop. It's the pressure is fluctuating here, pressure drop. Around 0.1 and 0.2, sometimes 0.3 I saw. Pressure drop we have, so we can just say that there is no pressure drop. There is, but very small, very tiny pressure drop we have, so we are happy with the pressure drop. So why and when the pressure drop is important? Why this operational variable is important in gas system, in gas networks? Just think about it, comment below, and thank you for watching this video. I just just one last thing. It's a very important thing. The last important thing is when you want to turn off your system, the first thing is just turn off the source of the gas, not the Bunsen burner. You can turn on the Bunsen burner, but it's better to turn off the source of the gas. You can see the Bunsen, all gas will be burned, and the pipes will be empty, and you can see how pressure will be dropped. It means that there is no gas inside the pipes. Okay, then you can close the main valves and switch off the emergency valve and turn off the Bunsen burner. And to save the batteries and power off the sensors, turn them off. And yeah. Thank you for watching the video. I hope you enjoyed and learned something new. And I would be happy to see your comments below. Let me know to improve the quality of the videos in the future. In the next video I will explain a little bit about hydrogen blends, the components of the natural gas. I will share you some slides, useful slides, practical. If you work in industry, it will be helpful for you, and also it will be helpful for you if you are a researcher or working in universities or research institutes. Please comments below and wait for the future soon coming videos. Talk to you soon.